Hello everyone. This session I will be discussing differential equation. What you need to study before your board examinations. Even those who are preparing for school examinations, they don't know. I'm not talking about everyone. Some students, they are either not informed properly or they have not understood what to study in differential equation. So step by step I'll tell you what to study over there and how to study in differential equation. What to study also very important here. Differential equation and learning outcomes, students will be able to note or explanation that if you go through this syllabus, you will see find the order and degree of differential equation, formulate differential equation, verify solution of differential equation, solve simple differential equation. No method it is explained here, just told solve simple differential equation. It means only separation of variable will be there. Simple differential equation, direct integration only. They have explained also here. But I have heard this question from many of you that the linear differential equation is there or not, integrating factor is there or not. These questions should not arise once you go through this syllabus. Solution of simple differential equations there, growth and decay model there. This is by using differential equations, you have to study the growth and decay model, their application in biological sciences, economics and business. If the business is profitable, then your profit goes on increasing. So there is a growth model. The business is growing, we say. Biological sciences, when bacteria culture is involved, the number of bacteria increases with time. That is also under growth model. Radioactive disintegration, there is a least chance of asking question on it, or Newton's law of cooling, both under decay model, but there is a least chance of asking question from there. Okay? But radioactive substance normally decays with time. That's why it will come under decay model. And if there is natural calamities, then population growth also decreases. That also comes under decay model. If anybody suffer loss in the business, that also will come. The amount of money goes on decreasing, or profit goes on decreasing. That also comes under decay model. So only this much is there in your syllabus, and tell me what have you understood. Just you have to study order and degree, definition also very important always, then formation, solution by separation of variable method, and then growth and decay model in practical areas. I will say that. Okay? Normally it happens in biological science, economics and business. That's why they have mentioned it like that. Now, for your board examination, let me start from beginning, that how to identify order and degree of differential equation. Before that, I must say what is our differential equation. This I must say. Yeah. A differential equation is that where you can express the equation in terms of independent variables, dependent variables, and differential coefficient of dependent variable with respect to independent variable. What is a dependent variable? Y depend on x. That's why write y equal to fx. So if an equation involves terms like x, y, dy by dx, these are derivatives, d square by dx square, together with their coefficients and some constants, then it is a differential equation. For example, if I write dy by dx equal to x cube minus 2xy, it's a differential equation. Number 2, say d square by dx square minus 4 dy by dx plus 7y plus 9x, this is a differential equation. Now, we have to study what is order and degree of differential equation. So, we are going to learn this now. We are going to remember it, better to say, because most of you have studied it. Order and degree of differential equation. You have to arrange, you can state the order and degree both if you have arranged the equation in the form of a polynomial. What is a polynomial? Polynomial cannot have a square root, cube root, or terms. Polynomials have finite number of terms like a0 x to the power n, a1 x to the power. You have the experience, you have seen this kind of things. Plus an, we write this one as ph, this is polynomial. If you can express a differential equation in the form of the polynomial, then you can state its order and degree both. Order can be stated even if it is not expressed in polynomial form. But for degree, remember, equations should be expressed in the form of polynomial. Okay? Now, what is order? Order means highest order derivative involved. Order means highest order derivative in the given differential equation. Abbreviation, differential equation. Degree means what? Degree means index of the highest order derivative in the given differential equation when it is expressed in the form of a polynomial. Polynomial of what? That, for example, I told you it is in the form of x, y, dy by dx. If you can express this form, then degree is defined. Otherwise, just you have to state order. So let me start with one simplest example to state order and degree. Like d square by dx square, 5 dy by dx, 7y. This is expressed in the form of polynomial. If you take some terms on right side, then you will be understanding better. So here, order is the highest order derivative. Highest order derivative 2, degree, index of highest order derivative. If nothing is there, you can write 1. So degree is 1. Index of highest order derivative. Okay? This is index of the highest order derivative. Now, can I state the order and degree in this case? 1 plus dy by dx whole square to the power 3 by 2 equal to, say, 10 d square y by dx square. Is it possible? Yes, it's possible. You just make square of both sides. Squaring both sides, what do you get? 1 plus cube 100 cube. We are squaring both sides. Square. Now, if you can expand this, then you get the polynomial. But the order will remain dy by dx here on the left hand side. Whatever is index, we don't care. We'll take care of index of this highest order derivative. See, by expanding left hand side, you will never get a term like this square by dx square. So you focus on it. Now if we expand, we will get a polynomial. This will be what? Polynomial of dy by dx or its square. Here, in this case, the highest order derivative is there and its index is 2. So we will see that order 2 and degree 2. Okay? This order and degree you have to state in many cases. I am going to discuss with you today. Like example 3 I am stating here. Say it is d square by dx square 1 plus under root dy by dx. What is the order and degree of this differential equation? You have to express it in the form of polynomial. Root is not, no way it is in the form of polynomial. So what I'll do here first, I'll write this way, then squaring both sides, equal to dy by dx. If you arrange it in the form of polynomial, the highest order derivative is this and its index going to be 2. So it's order 2 and degree 2. Why? You understood? We'll expand it whole square this is a differential equation whose order is 2 and degree is 2. Can we state order and degree of this differential equation? Say we have x square log of, say, d square by dx square. Left hand side you see it is in the form of polynomial. So order 2 degree 1, because its index nothing is there means 1 is there. But on the right side the term d square by dx square there, but its index is not there. So whatever degree, that will come as a whole, not for left hand side or right hand side separately. Similarly for order, everyone say 2, But as we cannot express as RHS is not in the form of d square by dx square, so is not in the form of polynomial, form of so degree is not defined. You will write your answer this manner. Degree not defined because you cannot express right hand side in the form of polynomial. Okay? So order and degree idea we have revised. Now we are going to discuss formation of differential equation. Formation means we have to form a differential equation from a Cartesian equation. Cartesian equation to the differential equation. Cartesian equation to differential equation. Then what does it mean? There will be a Cartesian equation. I have to get a differential equation by differentiating it. Now, in the Cartesian equation, some arbitrary constants are there, like y equal to mx plus c. M and c are constants. Okay? And differential equation, you have seen so many differential equations. Cartesian equation, this is for straight line. There may be parabola. There may be anything, circle. From there, I have to get a differential equation by eliminating these constants, which are known as arbitrary constants. Okay? And if there is an equation contain two arbitrary constants like m and c, how many times can you differentiate? Just think. How many times can you differentiate to remove m and c? Twice. Its order going to be 2. Think about y square equal to 4x. How many times can you differentiate this one? Once only, because one arbitrary constant. And if you differentiate once, order will be 1. Okay? So Cartesian to differential equation is obtained by eliminating arbitrary constants. It is quite obvious then order will be order of differential equation is equal to number of arbitrary constants given in the equation. Okay? For example, what is the differential equation of straight line? Straight line is this form, general form, gradient form, general form obviously. So if you differentiate, dy by dx will be m into 1 plus 0. Just differentiate again. What do you get? It is a differential equation of order 2. Two arbitrary constant, you can differentiate twice. So order 2. Alright? Now, you can try one before I move to next topic, formation of differential equation. You can try with this. write all the differential equation of parabolas whose axes are parallel to x-axis. Can you try once? Parabola whose axes are parallel to x-axis. I don't know whether you have done it or not. I am just showing you this parabola. Its axis parallel to this one. Okay? So in that case, equation will be x equal to ay square plus by plus c. Okay? If it was of this form, then you could have written, if it is of this form, then you could have written y equal to ax square plus bx plus c. Shifting of origin you have understood by using that concept only. Ax plus by plus c. So just write the differential equation of all the parabolas whose axes are parallel to x-axis. Just do, taking a challenge before I do. Write the differential equation whose differential equation of all parabolas whose axes are parallel to x-axis. Differential equation of all parabolas whose axes are parallel to y-axis. X-axis I have written there. Then it will be no, this one will be, sorry, this one for this parabola I wanted to say. For this parabola, this equation is valid. For this one, x equal to ay square plus by plus c. Never forget this. We need not prove it, but application is important. Ay square plus by plus c. So this is one case, axis parallel to x-axis. This is another case, axis parallel to y-axis. And you get y equal to ax square plus bx plus c. How to get the differential equation from here? Just differentiate. To ax plus b. This is dy by dx. So, differential equation of all the parabolas here whose axis parallel to, some mistake is there because if we differentiate again this one, it will be 2a, not 0. Now differentiate. This cube y by dx cube equal to 0. This is differential equation whose axis parallel to the y-axis. So if a problem arises this manner, by now you can write this form directly. Relate equation of parabola with this. d cube y by dx cube equal to 0 or y equal to x square plus bx plus c. In this case, what will you get? D cube x by dy cube equal to 0. If you differentiate term by term, dx by dy 2ay plus b, second order is what? 2a dy by dx plus, with respect to y you are doing, so plus 0, but then put the value of a or differentiate again, then you get the equation of this one. So this is the differential equation whose axes are parallel to y axis. The cube x by dy cube equal to 0. Clear? So do form another equation. I mean, just from the differential equation. Next question. Form the differential equation write the differential equation by eliminating m and c, that is a square minus x square. You can see the arbitrary constant. It will be based on that. You can differentiate once only, not twice. No, not twice. They said m and c arbitrary. So it's fine. Do it. Differentiating two y dy by dx this is number 1. You can differentiate once more, not more than that. So differentiate again. It is so this is the differential equation. It is of order 2 because two arbitrary constants m and c were there. This way, by eliminating arbitrary constant, you can form the differential equation. Okay? Just do one more for formation. From formation, form the differential equation. Next question. Form the differential equation of all circles in the first quadrant which touch the coordinate axis. Form the differential equation of all circles in the first quadrant which touch the coordinate axis, which touch the coordinate axis. How you do? How to answer this question? Just use your common sense of finding equation of circle. Circle will lie in the first quadrant. It is given. Okay? and it is touching both x and y axis. Clear? So question is the differential equation. How to get? You can start this manner. It's touching both the coordinate axis. So center has the same coordinate. Okay? Just a minute. I show you in a bigger diagram. It is better. Yeah, this thing. Just center is changed. Sorry, this is erased. Yeah, this one. This difference is no other information given. Only given circle touching coordinate axis in the first quadrant. So, from center, you know, if you draw a perpendicular, that is going to be radius. Radius be A, so its equation will be A comma A. Clear? So, what will be the equation of circle? Equation of circle is x minus a whole square y minus a whole square equal to a square. Hope you have understood. Now we have to frame the differential. This is just condition. You think how to get. Okay, so this will be divide both sides by 2. This is equal to 0. Now, you differentiate once more. There is no issue. You can do it always. But we have to keep some easiest step. Easiest concept before we do. We are writing, take a wala term on the right side. 1 plus dy by dx, isn't it? So a equal to this divided by 1 plus dy by dx. Check once the value of a I got. Okay. Now a is not eliminated, still there. So differentiate again. Dx of a square, no, a only. Differentiating again, a equal to so 1 plus dy by dx whole square. One plus derivative. X derivative is 1 plus dy by dx. Just a minute, plus sign will be enough. The writing product rule, this into derivative of this is dx by dx 1, dy by dx whole square, khatam. But this dy by dx of a is 0. So this is the required differential equation. You cross multiply, you simplify, you definitely do simplification. Whatever you do, have you checked my calculation? 1 plus dy by dx into 1 and dy by dx whole square. Minus sign I forgot to put. Minus sign I forgot to put. So differentiating again, just to differentiate again to eliminate arbitrary constants. Eliminating what? What to eliminate? Nothing to eliminate. Just simplifying. You can do it just by simplifying. We'll get the equation. Okay? So I am waiting for that because of this reason. Or you do it, no problem. Here you write this part, no, this part is there. This into derivative of this. You have done, it's fine. But that into derivative of this also can be involved. So go by product rule. Numerator into derivative of numerator minus numerator into derivative of denominator. So derivative of 1 plus dy by dx, it will be 0. This is the answer. Okay? This will be the differential equation. So formation you have understood. Now, to verify whether a given function is a solution of differential equation or not. To check whether a function of whether a function of y, not dy by dx, satisfies the given differential equation. Okay? Like I am going for example state. Okay? Just I am going for one example base. They have asked you to check. They have asked you to check whether or this kind, so that, sorry, so that y equal to plus b e to the power minus x is the solution of the differential equation. I am writing here, that is d square y by dx square minus dy by dx minus 2y equal to 0. You have to check whether y equal to a to the power 2x plus b to the power minus x is a solution or not of this differential equation. How to proceed, I show you in one sum. Y equal to just differentiating we have differentiated, we can substitute there. But we will do after finding second order, this part. This is equal to twice a into 2 plus b to the power minus x. Now, all these dy by dx, d square by dx square, you have to substitute there. If it satisfies, then it's fine. Just check. This y dy by dx and d square by dx square satisfying it or not. Put the values there. LHS is what? We got d square by dx square. Plus b is to the power minus x minus dy by dx, this value. LHS is this and minus 2y, that also you have to put. Minus 2b to the power minus x, these two, 3 get cancelled fully. 4a and here twice a get cancelled. So you can state that, therefore, given function is a solution to the differential equation. Sorry. Therefore, y is a function of, is a solution of y equal to what? That a to the power 2x, b to the power minus x is a solution of differential equation. Clear? This you can check. Just check once more whether it is a solution or not. You just check. I am writing the equation x dy by dx plus y equal to y square and y equal to a by a plus x. Check whether it satisfies the left hand side differential equation or not. Checking is there in CBSE applied math syllabus. Please remember this. So start. I'll wait, check whether it is solution or not. Y equal to a by a plus x. You can put it directly. You can do some manipulation to get it easily. It's up to you. Will you check or I do it? X dy by dx plus y equal to y square. Just find dy by dx. So it is 0 minus a into 1. A by a plus x whole square. Just put it there. Left hand side x put there plus y minus y square. We are finding this, no? LHS, RHS, whatever. We are finding both. The result will be 0, then it will be sure. Okay? So I think this is not possible to prove 0. X divided by dx plus y equal to y square. This cannot be a solution. You all can try. Then you support me. Without doing, no support. Do it, then I try to say something. As per my opinion, it is not. But check. It's not coming 0. Even if you take a plus x whole square LCM, that will never come. It can never be 0. So this is not a solution. Answer will be that this cannot be the solution of the given differential. Copy it, try it at home and report whether what I told you correct or wrong. Is that clear? So do one more sum of this type, whether it will be a solution or not. Just I'm saying. You do with this. Cx plus two c square plus c cube. Oh no, this I change. This is very big. I should not take this big question now. Comparatively shorter sums I have to find. Like y equal to a by x for this. This check once whether it will be solution or not. Y equal to a by x plus b. A by x, b is not with it. Okay? And d square by dx square minus 2a by x cube. Just put it there. Is it being satisfied or not? So it is their sum cannot be 0. Okay, so this is not a solution to the differential equation. Now, next I am going to discuss solution of differential equation. It is there in your syllabus. and this will be done by separation of variables. Only this method is there in syllabus, uh, no other topic you need to go through. Just we are going to solve some differential equations like this. I am writing here, like number 1, say it is dy by dx check. I mean solve. How to solve? Solution means I have to get here actually Cartesian to differential we did. Here we will be doing differential to Cartesian. To Cartesian equation. We have to get back the equation. So it means we have to solve. It means we have to integrate. Just separating the variable, dx you take on right side and y on left side. Just integrate both sides. Log y equal to this is the solution. This c is called, or c is the integration constant. So we got back the Cartesian. Okay? And where c is involved, then it is general solution of differential equation. We will be referring this as general solution of differential equation. Okay? But if there is a way of finding this c, that is called particular sum. So here c is not known. And when c is known, its value can be determined, then it is called particular solution. Is that where c is known. Okay? If c is known, then this is called particular solution. I am just writing one sum to get the particular solution here. Let us take this one, number 2, solve when x equal to 0, it is given. When x equal to 0, y will be 1. Then you can get the particular solution. So what we will do here, you will solve it like by using separation of variable, just you have done in one term, and then use the condition to get the value of c. Understood? So let me solve it. It is dy by dx, take e to the power y common. So dy by into dx. Integrating both sides, you take it up. Okay. So this will be now is the condition given there. Y is 1 when x equal to 0. Therefore, this is minus 1 by a and this is 1. This is the value of C. So required solution is what? E to the power minus y minus equal to so this is the required differential equation. Solution to the required differential equation. Clear? Take another one like xy dy y minus 1 into x plus 1 dx. What to do? You have to solve. And when x 0, y 0 given. So go by separation of variable. Y with function of y, dy with a function of y, dx with function of x. Better to say. Integrate y minus 1, this you write as by one into dx separate dy plus log x plus c. So y plus log of y minus 1 mod. Clear? Now is the initial condition. This is the initial condition. x0, y0. You take x1 better. Otherwise it will be undefined. x1, y0. Okay. So this will be 1 plus log 1 plus c. C is minus 1. So this is general solution. GS I am writing. And particular solution x plus log x minus 1. So differential equation in your syllabus till separation of variable what is there I have discussed today. One part just application is left. Let's see when I get some time to discuss application, that growth and decay model mainly with you. Thank you for staying with me. And one request for you, please don't be confused before exam by listening from here and there, this topic there, that topic there. No. Whatever there in your syllabus, that I have explained today. Only one part is left which I could not cover, that is application in daily life. That is growth decay problem, that model wala question. Okay? So this class is not to solve problem. This class to tell you what you have to do for your board exam.